LeetCode problem. Today we are solving this divisible and non-divisible sums difference. This is a very simple question if we use a for loop, but we are supposed to do in O of 1 without using any for loop. So what is happening is over here, we are given positive integers n and m and define the two integer as value. So nums1 is the sum of all integers in the range 1 to n, both inclusive, which are non-divisible with the m, and the sum num2 is equal to the sum of the all numbers in the range 1 to n which are the divisible by m. Then we have to return the num1 minus num2. You can visualize like this. So for example, n is equal to 10 and m equal to 3. So in this case, if you observe, these are the value starting from 1 till 10, right? So who all are the non-divisible by 3? These are the red, all the red one are the non-divisible by 3. So if we sum all those, what would be? It would be like num1 value. Okay, so num1, if we sum all of them, it would be 37, right? So its value would be 37. Now if we sum all the green icon which are divisible by this m, right? So 3 plus 6 plus 9, this is 18. So 37 minus 18. Okay, so our answer would be what would the answer would be? 19. Okay, so 19 should be our answer. This is what we have to show. So one simple way is we can use certain for loop and we can do that, but in by any chance if somebody asks in interview, we are supposed to do in O of 1 without doing anything. So what we can do here is, like, first of all, if we get the sum of all those numbers, we know that n plus 1 into n divided by 2, this formula gives us the all sum of the number starting from 1 till n, right? So if we do the sum of all, this will give 10 plus 1 into 10 divided by 2. So 55 would be the sum of all these numbers, right? Now what we will do is we will look for the all divisible numbers which are divisible by 3, right? So all the divisible number, first number would be always the m only, right? Because we start with the very first value. So this guy would be always same. So we can say that the start of term would be the this guy, always the n, right? So we can say first value would be always m. Okay, first would be always m. Now what would be the last divisible value? So if we want to get the last divisible value, we know that here, for example, in this case 10 is the last value of this series itself. So if we want to get the last divisible value, let's say we are calling last LD, last divisible value. Last divisible value would be whatever is the last value, like n in this case, right? N would be always last. So n remainder with the m. Okay, if we deduct this value from n, then it would always give us the last divisible value. So basically the formula would be n minus n m%, right? So this will give us the last divisible value. You can check here, if we put here 10 and the 10 m%, 3 would be 1 only, right? So 10 minus 1. So last divisible value would be our 9, right? So this would be our last term. Now we know that in this would be an arithmetic progression, right? You can observe here, this is first value, then this is second term, then this is the final term, right? So how can find that how many arithmetic progression numbers are there? So if we get the last divisible value, okay, divide by the common difference. So common difference would be m always, because we are looking for all the divisible value. So last divisible value divided by m will give us the how many total numbers are there. Okay, so total numbers would be last divisible value divided by m. Okay, so in this case we will get the first value, which is always m, and then we will get the last value, which we can get in this way, or like this. Okay, so first value and last divisible value, which we got n minus n% m, this will give us the last divisible value. So our LD would be this, right? Our first would be m, and our n would be, as we already got, whatever is the last divisible value, LD divided by m, right? So once we get this first, which is m, then last divisible value, which is n minus n% m, and n would be our LD divided by m, means the how many terms. So we will put this value in this formula. Okay, so we will get the sum of all the divisible values, right? So it would be looks like we will get the Sn. So how would we then find the Nm? So let's go ahead. Let me remove all. Num1 would be, means all the non-divisible values, how we can get. So if we deduct from sum of all, okay, from the sum of all minus sum of the divisible, right, minus sum of the divisible by m, sum of the divisible by m, right, this will give us num1, and we have to find the num2. So this would be like divisible by sum of all divisible by m minus this is basically our num1, right, sum of all divisible minus sum of all minus sum of all divisible minus one more time sum of, because this is n1, so n num1 minus num2, num1 minus num2 would be sum of all minus sum of all divisible minus sum of all divisible, because sum of all divisible is our num2, right? So this would be 2 times, this value would be 2 times. So we can say, if I remove this thing, we can just say that its value would be sum of all numbers minus 2 into sum of all non-divisible. So it would be 2 times like this. Okay, so with this formula we can find the value, and we don't have to go any for loop or anything. So this is how it would look. See here, first of all, what I'm doing, I'm getting sum of all the numbers. In second one, what I'm doing, I'm getting the last divisible value by n. Okay, last term of that arithmetic progression, that would be n minus n percent m. Okay, now number of terms we have found, that would be whatever is the last divisible value, which is n minus n percent m divided by m, right? For example, in this case we already found it here. See here, first is 3 and last is 9. Then how many number of terms? 3, 6, 9. So how we can do that? 9 divided by 3, right? So it would be like 3 terms. You can check here, this arithmetic progression has 3 numbers only, 3 and 6 and 9. So total 3. So for that reason, we have found the number of terms, we have found the last divisible value, and first value is always m. So see here what we are doing, we are making sum of all minus number of terms into m plus last divisible value. This will directly give us our solution, because we are looking for num1 minus num2. Okay, so let me execute this code and let me submit it. So we are not using any for loop, we are just using some formula. So this would be 100% faster. So thank you for watching this video, and if you guys have any concern, please make a comment over there. Thank you.